Hello, AP Physics 1, it's Mr. Ng with number 4 out of your energy review set. I'm not a huge fan of this problem because the majority of the thinking is about trigonometry or geometry, but it does go over MGH. So here, let's go through it. So we have this, I'm going to draw it a little bit bigger. We have a situation where this pendulum is being swung around and it wants to know the difference in energy. Right? The difference in energy is actually the difference in height. So here, let's draw this across. So we want to find this value. What in the world is that height? And to find that, it's not so hard. The length of the string is L. So we know that the length of this string is also L, right? Now, what in the world is this part? This weird part, well, if we do a little bit of trigonometry, here's theta. This is going to be L cosine theta. I know some of you might be looking at it and say, oh, it's vertical, it should be sine. It's sine only if the theta is against the horizontal. In this case, the theta is against the vertical. So I'm just going with the old rule of like cosine for adjacent, sine for opposite. And as you can see, it's adjacent to the angle, so I'm using cosine. So that means H is equal to the whole thing, right, which is L, minus this bit, which is L cosine theta. That's pretty good. And then now I just got to add the mg to it because I know that energy, potential energy, is equal to mgh. I'm going to substitute in h. That means it's equal to mg L minus L cosine theta. That's a pretty good answer, but it wasn't in the answer key, so I could just take the L out. So this will be mgl times 1 minus cosine theta. Good. That is the answer.